Hey geometry students, how you guys doing? Looking like we're gonna have some possible freedom pretty soon. I mean, May 15th is coming up, but we're still quarantined. Hope you and your family are doing well. Okay, we're gonna keep moving in section 12.4, working with volume of prisms and cylinders. First off, we need to talk about what is volume. Okay, best way to think of volume is what is going displacement. Okay, that's probably not a word you've heard before. One of the ways volume was measured back in the day was by displacement. So you'd fill up a tub of water and you wanted to measure something heavy, then you would fill the tub of water up, and then you'd take that heavy object and put it in the tub, and then how much the water grows or changes, in this case how much it increases, okay, would be volume. So if you've ever taken a bath in your life, when you fill up the tub and then you get into the bath, the amount the water, so if you fill it all the way to the brim and then you get in it, which is a waste of water by the way, but if you get in it and it overflows, well, that stands to reason. You have volume. You occupy space. Well, occupying space is definition of mass, but they're kind of related. But I'm going to go off on a tangent here, so I better stop myself. So if you remember from physical science, density equals mass divided by volume. That's kind of how they're related. But so something's more dense, then it's going to have a greater mass and a smaller volume. Okay. Something that's less dense, like an ice cube, is going to have mass but a lot greater volume. It's going to be spread out over a larger area. Okay, so the bigger this number is, then the smaller this number is. The bigger this number is and the smaller this number is, the greater this number is. Okay, so we want to find the volume of an object. Okay. Your definition in your book says volume of a solid is the number of cubic units contained in its interior. Okay, the postulates are pretty important, and really you can take a look at those. All right, but the one I definitely want you to make sure that we focus on is this one, because that's how we would do something like this one. The volume of solid parts is the sum of all the non-overlapping parts. So if you were to find the volume of this sucker here, the way I would do it is take and cut, like I would take a saw and then I would cut this chunk, this called a rectagonal prism. Why is it a rectagonal prism? Because it has a rectangular base here, and there's its height. It's laying on its side. Okay, this would be another rectagonal prism, and cut that part off. Okay, and then this down here, this whole one here, you can see, would be another one. So the formula for me would be this prism plus this prism plus this prism. Okay, you can't do this all at one time. You'd have to do this one, and this one together. The formula for a rectagonal prism is really, really easy. Okay. So, if you look at your book, the formula says volume is base times height. Okay, but wait, that's not base. Okay, little b is base. Alright, capital B in geometry stands for area of base. Okay, so big B is not like it's not a length. It's the area of the base. Okay, times the height. Okay. So if I wanted a trigonal prism here, okay, if I wanted a trigonal prism, if I drew that, okay, and then I did that, all right, that'd be a trigonal prism. As long as these bases, okay, in order to be a prism, okay, in order to be a prism, these have to be congruent bases. Okay, these bases have to be congruent. All right, so this would be a prism called a trigonal. Okay, that's the way you say what type of prism it is the base, whatever the base shape is. So if it's a triangle, it's trigonal. Okay, it doesn't have to be regular, all right, but it has to be. These have to be congruent. Okay, if it's hexagonal, then it'd be hexagonal prism, pentagonal prism, etc. That's telling you that the congruent bases are, in that case, a pentagon. Okay, so let's go to guided practice number 1. Take a look at that one in your book. All right, so the first one in your book has something like this. Find the volume of this. Well, again, if I were to take a piece of paper or like a saw and cut this part off. Okay, so now I've got a rectagonal prism. Rectagonal. Well, actually, it'd be a square prism. All right, it's actually a cube. I've got a cube here. Okay, the volume of a cube would be side times side times side. Okay, cube is side cubed. Okay, but that's all. We could also use our formula here. So the formula here is going to be volume of cube plus volume of rectagonal prism. Okay, so it's going to be this one plus this one. Okay. Okay, so the cube is going to be area base. So if I chose this as the base, this backside is going to be base. So 1 times 1, and then the height is 1. So 1 cubed essentially. And then the volume of the rectagonal prism, this is going to be its base. Okay, so 2 times 1 multiplied by this being its height. I'm having this on its side. You could have done it the other way. You could have done this as the base, and the backside is the base, and then this being the height. As long as the bases are congruent shapes, that's fine. Okay, so let's move on to our next one. All right, so hopefully you pause this and take a look at guided practice number 2. It's asking us for the volume of a square prism. All right, I don't need to draw the shape, but sometimes I do if I need to give myself a mental picture, but I can kind of see, okay, it says edge length is 5. Well, it's square prism, so we already know that if it's 5, the other length is going to be 5 because it's a square. And then they told us the height is 12. So volume is area of the base times the height. 5 times 5 times 12, 300 feet squared. They gave us feet. But again, I sometimes drop the units in the work and then put it there. If I was physics, no way, I'm not going to drop the units in the work because we often have like meters per second or meters per second squared. So, all right. So the next one, they tell us to find the volume of a right cylinder, or not, they gave us the volume of right cylinder, but again, right cylinder means it's standing upright. It's not leaning at an angle. The base, there's an oblique one, and you can see in your book. They give us volume. Okay, volume was 684 pi inches cubed. Okay, so we've got volume. Okay, and they tell us to find radius. Well, this is the formula for the volume of a cylinder, but I don't like that. I want to change that because I know what the formula for the area of a circle is, since this is going to be a circle, even though we draw it as an ellipse for drawing's sake. So V equals 2 pi, oops, not 2 pi r. Okay, sorry about that. Volume is the area of a circle is pi r squared. So pi r squared h. Okay, so this is what I would do, but you're not me, but I love solving by variable. The variable I want is r, so I would solve by the variable r. So the first thing I would do is divide by, since these are all under multiplication, I would have v divided by pi h equals r squared. I want to solve for r. R is now going to be the square root of this whole quantity. Okay, you're starting to get more sophisticated in your math, and this is something that you should be able to do, solving by variable. Okay, so I divided both sides by pi h, get pi h to the other side. Okay, they become 1 on this side, and then pi h here, then take the square root. Okay, so plugging the parts where they belong right here, this is volume, and then notice the units pi, they cancel, they become 1. And then 684 divided by 18 is 38. 38 is not a happy number, so we can't go any further. If I divide by 2, it's 19. 19 is a prime number, can't go any further. So we can leave it in radical form, totally fine. All right. Okay, so there's the next theorem of Cavalier's principle. It's kind of nice. I'm probably not going to find any problems with it, but it only works for volume. Don't try it for surface area. But it basically is saying if you've got the same cross section throughout the whole thing, if you were to take and cut this in little slivers and then add them all up, then as long as the cross section is the same throughout the whole thing, then the formula over here, this formula is valid, or these formulas are valid. So taking this guy right here, since these are all going to be the same circle, okay, then if I cut these up, these circles are going to be the exact same area, then this formula does indeed work. The only difference is the height is not this distance, okay? Height would be this distance, okay? Good, don't have that over there. So, oops, I had the answers over there. I didn't want to give you all the answers. So, let's take, again, volume. One way to think of volume is like how much water would take, like how much would it take to fill this up, okay? Well, now we're dealing with a different situation where this is empty space, okay? I got a big old block cut out of this. So this is empty space right here. So the rest of this is all solid, but this would be an empty, what was it? Is it as congruent? So it'd be a square prism right here cut out of this. So let me put the units. Okay, so put the units in. I think these are all in feet. Okay, so the volume total is going to be the volume of the trigonal prism. Okay, so this would be its base, and this would be its height. I know it's on its side, so if you wanted to turn it, okay, then you can see it standing upright. Okay, but it's on its side, so this would be the height. Okay, this would be the repeated base here, because that would be the base. I could draw the back side back here. Okay. Anyways, so we need the volume. Oh, start with the easy one. We'll need the volume of this. Okay, the volume of this is easy. It's going to be base area of the base times height. Well, that's a square, so I'll put that one in right there. That's going to be b times h of that. So that's going to be 3 times 3 times 6. So that one's easy. 3 times its height, which is 6. Okay? Well, what about this one? Well, this one, the height's easy. It's right there. But we need the area of this. And we know that for polygons, for regular polygons, we have this one, 1/2 ANS. Or you usually use 1/2 AP. Okay? You take what you got. Make life easy. Okay? I could do that. I could definitely draw center and then try to find the apothem from there, from the central angle. Okay? But with this, I have something easier, because I also have another formula for a triangle, which is 1/2 base times height. Well, I have base, and I need the height of this triangle. So if I needed that, okay, I need this height there. Got this whole length to be 10. This is going to be 6. That forms a right angle. I think I could find that. Oh wait, that's not right. Oh, boop. Oh no! Whew, the document camera was blocking my view. So, okay, crisis avoided. I have to pay attention to my congruency symbol. So this is congruent. I put it on the back side here, but it's in yours right there. So this is an equilateral triangle. So it's 10 by 10 by 10. Okay. Well, I like to break it down further. Okay. So if this is 10, and we want this, so I'll just call this height, and this is the height of the base. And this is not 10. Okay. This is definitely not 10. This is going to be half of that distance there. So that's going to be 5. Okay, so I'm looking at the time and going, oh! Okay, so 1/2 base times height, got height. This is base. Okay, so 1/2 height, multiplication is commutative. So 1/2 height times base times the height of the prism, okay, which is this one. It's hard, don't get this height of the triangle confused with this, okay? Minus that, booyah, booyah, booyah. 205.81. I am out of time. I'm going to end here. May the good Lord bless and keep you, and I'll post the homework problems to do. And all right, have a great and wonderful day.